Hey guys, Mrs. Scheffler here. This evening we're going to be practicing how to multiply fractions and whole numbers. So let's take a look at our essential question really fast. And it says, how can you use a model to show the product of a fraction and a whole number? So, under our investigate problem, we'll see the word problem we're going to be working with. It says Martin is planting a vegetable garden. Each row is 2 meters long. He wants to plant carrots along 3/4 of each row. How many meters of each row will he plant with carrots? Alright, well let's go back and take a look at this word problem and pull out the key information we need to work with. We do know that we will have to underline our key question, so that is how many meters of each row will he plant with carrots? Now let's try to find the other key information or numbers that we need to work with. It says each row is 2 meters long and he wants to plant carrots along 3/4 of each row. So let's kind of build a model off of that. Let's take a look down at the bottom. It says to place 2 whole fraction strips side by side to represent the length of the garden. And if you look down here, they have done that. We have 2 whole fraction strips. We've placed those side by side, and those are going to represent the length of the garden. The next thing we need to do is to find 4 fraction strips, all with the same denominator, that fit exactly under the 2 holes. Well, if we go back up and look at our word problem, we see that our denominator is 4. So when we build our fraction strips, or when we draw our fraction strips below each of these 2 holes, we know that we need a denominator of 4. So let's go ahead and draw that. And keep in mind, I'm kind of drawing free-handed, so it's not going to be perfect. Okay, our next step, it says to circle 3/4 of 2 on the model you drew, which means that we need to circle 3/4 on this side and 3/4 on this side. So let's go ahead and do that. There's 3/4 and there's 3/4. So now it says to complete the number sentence, 3/4 times 2. And let's keep in mind, anytime we have a whole number, we can think of that whole number with a denominator of 1. So 3/4 times 2 equals, well, let's see what we have on each side. We circled 3/4 on this side, so that's 3, and 3/4 on this side, which is 6. And as you can see, 3 times 2 equals 6. And if we multiply our denominators together, 4 times 1 equals 4. Now, in order to simplify that, we can actually do it one of 2 different ways. We can think of a number that both the numerator and the denominator can be divided by. And since we've gotten pretty good at our multiplication facts, we know that both the numerator and the denominator can be divided by 2. And remember, whatever you do to the numerator, you have to do to the denominator. So 6 divided by 2 equals 3. 4 divided by 2 equals 2. So we know that 6/4 also equals 3/2. Now, Martin will plant carrots along 3/2 meters of each row. Now, we also know that since the numerator is bigger than the denominator, that we have a fraction greater than 1. So anytime we have a fraction greater than 1, we can actually turn that into a mixed number by dividing the numerator by the denominator. So we can do 3 divided by 2. We know that 2 goes into 3 one time. 1 times 2 is 2. 3 minus 2 equals 1, and our denominator stays the same at 2, so we can actually have 1/2. So 3/2 or 1 1/2 meters of each row. Now let's look under the Draw Conclusions section. Explain why you placed 4 fraction strips with the same denominator under the 2 one-hole strips. Well, we know we did that. Well, we know we wanted to divide the entire length of the two holes, 1, 2, into 4 equal pieces, which we did 1, 2, 3, 4, 1, 2, 3, 4. And the 4 1/4 fraction strips did that. Okay, so let's take a look at our second question. It says, explain how you would model 3/10 of 2. Well, to model 3/10 of 2, first I would show the 2 holes and then place the 1/10 fraction strip under each of the 2 holes. I would use the 1/10 fraction strip because our denominator in the problem is 10. Then I would go back and circle 3/10 under each of the whole numbers and then count up the ones I had circled, which would then be 6/10, and 6/10, as we know, we can divide each side by 2, so 6/10 can then be reduced to 3/5. Now let's further connect these by making connections within the next word problem. So in the investigate, you multiplied a whole number by a fraction. You can also use a model to multiply a fraction by a whole number. So let's take a look at our next word problem. It says, Marco was helping clean up after a class party. There were 3 boxes remaining with pizza in each. Each box had 3/8 of a pizza left. How much pizza was left in all? Well, let's start off with underlying our key question, or the question we need to answer in the word problem, and that is, how much pizza was left in all? Now let's find the other key pieces of information we need to use from this word problem. It says Margot was helping clean up after a class party. There were 3 boxes remaining, 3 boxes left over with pizza in them. Each box, so each of the 3 boxes had 3/8 of a pizza left. And our question once again was, how much pizza was left in all? So we can actually model these using fraction circles. So the very first step we need to do is to find 3 times 3/8. Well, we know that 3 is a whole number, so we can represent our whole number as a fraction over 1. So 3 over 1 times 3/8. So we know that anytime we multiply, the very first number represents the number of equal groups. So in this case, we're going to have 1, 2, 3 equal groups. Now our second number represents how much we have in each of our groups. And we have a fraction of 3/8. So we know that in each one of these, we will need to shade in 3/8 of the pizza. So let's go ahead and do that. And remember, kind of free-forming this, so it's not going to be perfect. There's 3/8 in that one, 3/8 in that one, and 3/8 in that one. So we can actually go, there's 3/8 in this one, 3/8 here, and 3/8 here. Now, the really cool thing about multiplication is nothing more than repeated addition. So when we look at 3 over 1 times 3/8, that is going to be the same thing as looking at 3/8 plus 3/8 plus 3/8. So now let's take a look at step 2. It says place 1/8 fraction circle pieces on each circle to represent the amount of pizza that was left in each box. We already did that when we shaded it. So each circle shows, and we've already written this out, each circle shows 3/8 of a whole. The 3 circles show 9/8 of a whole. And that's if we look at 3/8 plus 3/8 plus 3/8. Well, 3 plus 3 plus 3 equals 9. And we know when we add, we do not change our denominator. Our denominator stays the same. So 3/8 plus 3/8 plus 3/8 equals 9/8. Or if we come up here and multiply it, we know that 3 times 3 equals 9, and 8 times 1 equals 8, 9/8. So we've already completed this problem, 9/8, and 3 is 9/8. So Margot had 9/8 of a pizza left over, or we know that 9/8 is a fraction greater than 1, so we can take our numerator divided by our denominator. 9 divided by 8 is 1. 1 times 8 is 8. 9 minus 8 is 1. And our denominator stays the same at 8. So we had 1 and 1/8 box of pizza left. All right, let's get those math journals out and let's copy down our math notes for today. And today we've been talking about fractions by whole numbers, multiplication, and we learned a couple of different things. Just most importantly, when you're multiplying by a whole number, that whole number then goes over 1. You multiply your numerators together, you multiply your denominators together, and you simplify it or you reduce it, whichever the case may be. Now let's take a look at our password for the day. Yesterday we were talking about decimals. We're going to kind of stick with that because I know that was one that you guys kind of had an issue with. So let's look at adding decimals together. 131.25 plus 67.78. Now we remember when we were adding decimals together, your decimal points always stay aligned. So we bring our decimal point straight down first of all, and that's the very first thing that we do. Then we can add it just like we would add any other problem together. So 5 plus 8 equals 13, carry our 1. 7 plus 2 is 9, plus 1 is 10, carry our 1. 7 plus 1 is 8, plus 1 is 9. 6 plus 3 is 9, and bring our 1 straight down. We have our decimal in place, so this is 199 and 3/100ths. This is your password. Be sure you bring this to class with you tomorrow.